Hi and welcome to another Motec webinar. My name's Pete Swinney and today's subject is setting up knock control in an M1 ECU. Okay, so the knock in the M1 is very similar to the M800, or at least the setup is. The M1 is very different when it comes to how the knock is actually measured into the ECU. On an M800 you need to use an SKM to amplify the knock and help gate the signal. On an M1 this is all done on board through DSP inputs. So in other words, you can wire a knock sensor straight into the M1 ECU. On our M130 range of ECUs there are two knock inputs, and on the M150 series there are up to 4 knock inputs available. Alright, so how the M1 works is it uses 4 different frequencies that you get to specify to measure the knock signal. You assess through logging the best frequency that shows up the knock at the worst level, and then modify the 4 frequencies again to center in on the frequency that's most suitable. And the most suitable frequency will show the most knock level for the least background noise. Alright, so the settings for the threshold, the gain for each of the cylinders, so you can equalize the output of individual cylinders using a single knock sensor, and you can apply different trims for different amounts of knock over the threshold limit. You've also got a recovery rate. Alright, so just spread out here we've got the threshold. It's very similar to the M800. It's just a table that you enter. Basically you want this threshold level to be above normal background noise at full load, and that's available over different engine speeds. The gain, this used to be a single number in the M800. Now this is you're able to put this over different engine speeds, and so this is the amount of ignition retard per percent of knock signal above the threshold. And the cylinder knock level gain is here. Now this is it's percent per volt. So normally we would start with 100% per volt in all of your cylinders, and then do some logging and have a look and see what the cylinder balance is looking like, and then modify the individual cylinder gains to make sure that at full load and at higher RPM where knock is more likely, that you have all your knock voltages or knock percentages all at a similar level. And the window width in the M1, this is best just left to 60 degrees. You have a start point, but the window width is we've had very good success with just leaving that at a 60 degree window. So here's an example of what the parameters would look like and for a given single knock event. So in the case you see here, we've got an example where the gain is 50%. So this is 50% of the amount of knock measured over the threshold. So here we have our background noise here from our individual cylinders, and in this case looks like a 3-cylinder. It's probably going to be a Sea-Doo. And we've had a knock event on cylinder 3. The darker blue line here is the threshold, so its level is currently 43. The knock event peaked out at a 72%. So if this was 100% cylinder gain, 100% per volt, then you're looking at approximately 0.72 of a volt out of the knock sensor at that point. Right, so there's a difference of 43% between the level and what the knock event was measured at. Right, so you subtract that out and you end up with 29.7 degrees, or near enough to 30 degrees. Alright, now we've got a knock gain of 50% in our example. So what this means is 50% of the total knock percentage that goes over the threshold. So 50% of 30 degrees is 15, or 14.9 of 29.7. Right, so that means that the ignition would be retarded by that amount, and that is of course if unless you've got a clamp on your overall amount of ignition that can be retarded. So what we're going to do in the next webinar is go to a live engine, and we'll go through the setup in tune, and we'll do a little bit of logging and setup and let you see how it's done. Thanks for listening, and catch you next time.